So the voltage at A is the voltage at C, which is 12, minus the drop across the 4 ohm resistor, which we just calculated to be 3.7647. And so the voltage, the absolute voltage, I guess you might call it at, let's see, get my calculator out. This is I don't need a calculator for this, 8.235 volts. Okay, so now we've calculated that, and let's put that together up on the top, shrink it down, and we'll start another column. Okay, so I'm just going to make a little separation here, and we'll continue our manual analysis. Okay, so we know the voltage then at point A. The next step, of course, would be to find the voltage at point B. Okay, how would we do that? Well, we know the voltage at point B would be the current I1, which is flowing across element B, times 5 ohms, okay? So the voltage at B is equal to I1 times 5 ohms. And so the voltage at B, I1 we said was 9.9412 times 5 gives us the voltage at B, and we get the calculator out. If I multiply that, we get 4.706 volts. Now, as before, we would want to find the drop across B, but since the voltage at node D is 0, the drop then is in fact equal to the voltage at B. All right, now having found the voltage at A and the voltage at B, we now don't know the drop. Oops, I have to get my pen out. We know the drop across AB. Okay, so the voltage across AB is just the voltage at A minus the voltage at B. Okay, and so we can find that quite simply. Let's just call that VAB, make it a little bit shorthand, and that would be equal to 8.235 minus the voltage at B, 4.706, and this one I know I can do in my head. Voltage AB is equal to 3.529 volts. Okay. All right, now we're going to shrink that up too. I'll shrink this up. Having found the voltage across AB, we can now find the current, I2. How can we do that? If we know the voltage across AB is going to be equal to the 6 ohm resistance times the current I2. Okay, so now I2 then becomes the voltage that we just found, 3.6, let me just delete that. Where am I now? The current I2 is equal to the voltage that we just found, 3.529 divided by 6. Okay, so this current I2 would be equal to 0.5888 amps. All right. So now we found I2. We're almost there. Our last remaining task is to find I3. And that's pretty simple because we know that I1, oops, I have to get my pen. We know that I1 is equal to I2 plus I3, and we know I1 and I2, so I3 is equal to I1 minus I2. I3 is equal to I1, what is that again? Way over there, 0.8, 0.94, 1, 2, minus I2, which we just calculated, 0.588. And, ouch, I'm going to sprain my brain on this one. I3 is equal to point, it's not a 4, it's a 3. It's not a 5, it's not a 13. 3 amps, I think. All right, so I think we've got it. By Jove, we've got it. Let me shrink that down again. And we can summarize what we've done a little bit. We'll just put that up here. That's our final result. And oh, I need my pen again. And so what we found is let me get the other pen out. By using this approach right here to find the equivalent resistance of the entire circuit, we were able to find I1. And I1 is right here. Okay. What did we do next? The next thing we did to find I2 was we had to go and find the voltage drop across AB. Okay, we found the voltage drop across AB right here. And then we used Ohm's law to calculate I2. And we have the following result here. So we have the current I2. And then finally, we used conservation of charge and our friend subtraction to find I3. And so we found all of the current in each branch of our circuit. We also did this by finding voltage drops across the various elements. In our next screencast, as you can see, this is quite a laborious process. Our next screencast will use matrix methods, and these matrix methods will allow us to perform this operation in a simpler way. At least the calculations will be more straightforward, but it's important to know how to do it in a manual way so that we really understand what's happening. And a key thing to understand is this process right here, where we had to find the voltage across A and B in order to manually calculate the current I2. The voltage at A is higher than the voltage at B, and so the current will be pushed across the 6 ohm resistor. And I think that's kind of the heart of it. And the way we do that is by first figuring out what I1 is, by breaking down the circuit into a simpler form by finding the equivalent resistance.